Hello friends. We talked about in one of our sessions we talked about quadrilaterals having specific types, and one of those was parallelogram. So now in this session we're going to talk about the diagonal related properties of parallelograms. So we'll first of all start with the definition of a parallelogram. The basic definition as per the Euclidean geometry is that a parallelogram is a quadrilateral with two pairs of parallel sides, which means AB is parallel to CD and AD is parallel to BC. So this is the basic definition of a parallelogram. So friends, let's take the first theorem, which is related to the diagonal of a parallelogram. The theorem states that a diagonal of a parallelogram divides it into two congruent triangles. So let's take this parallelogram, which is ABCD, where we say that AB is parallel to DC and AD is parallel to BC, and AC is the diagonal which divides this parallelogram into two triangles, which are ACD and ACB. Now we know that in these two triangles AC is equal to CA, which is the common side of the two triangles. We also know that angle ACD, this angle, is equal to angle BAC, because by the basic definition of the parallelogram it has two pairs of parallel lines, and AB is parallel to CD and AC being the transversal, these two will be alternate angles and hence they would be equal. Similarly, angle BCA will be equal to angle CAD. These are also alternate angles with AD parallel to BC and AC as the transversal. So now this angle is equal to this angle is equal to this angle, and this is the common arm. So the two triangles ACD and CAB are congruent to each other by the ASA rule of congruency. So hence we prove this theorem, and this will be always true for a parallelogram. Let's move on to the next theorem. The next theorem states that the diagonals of a parallelogram always bisect each other. So now here we have the parallelogram ABCD, and we've drawn the diagonals AC and BD here. Now we'll take these two triangles, triangle AOD and COB. Now here we know that angle OAD, which is this angle, is equal to angle OCB. We also know that angle ODA is equal to angle OBC, and we know that AD is equal to BC. So based on this, the two triangles are congruent. AOD is congruent to COB based on the ASA congruence rule. Now we can say that the basic definition of parallelogram does not state that AD is equal to BC, but we'll see in another session, based on where we talk about the properties of parallelogram related to the sides and angles of a parallelogram, we will see that the two parallel sides are also equal. So AD is equal to BC. So we'll see how do we reach that conclusion based on a theorem. So these two triangles are congruent by the ASA congruence rule. Now based on this, if these two triangles are congruent, we can say that AO is equal to OC and DO is equal to OB, which is CP/CT, which is the common parts of the the corresponding parts of the congruent triangles. So with this we conclude that the diagonals of the parallelogram always bisect each other. And now if we look at the converse theorem, it says that if the diagonals of a quadrilateral bisect each other, then it has to be a parallelogram. So again we have the same thing, we have the parallelogram and we have the two diagonals drawn here. So now in this, so we actually have a quadrilateral ABCD with the diagonals and such a way that the diagonals are dividing each other into two equal parts. So they are bisecting each other. So now in this quadrilateral ABCD, we'll again take the triangles AOD and COB. So we'll take this triangle and this triangle, and we know that AO is equal to OC, which is given because we are saying that the diagonals are bisecting each other. And we also know that DO is equal to OB. Moreover, we know that the angle AOD is equal to angle BOC because they are the vertically opposite angles. So now this says that triangle AOD is congruent to triangle COB by SOS congruence rule. Now since these two triangles are congruent, we know that AD is equal to BC. Similarly, if we take this triangle AOB and COD, again we have DO is equal to OB, AO is equal to OC, and we have this angle AOB equal to angle DOC, and these two triangles again are congruent by SAS congruence rule, and we can say that AB is also equal to CD. Now again in the we have another property of a parallelogram which says that the opposite sides are equal, then it's a parallelogram. So since we've proven that AD is equal to BC and we've proven that AB is equal to CD, so we are saying the opposite sides are equal, that means it's a parallelogram. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.